My name's Paul Wolf, and today we're going to look at length, area and volumes and how they're related in similar objects.
We're going to establish the LAV rules, length, area and volume. See what I did there? And we'll look at LAV made simple, how a simple table can make answering any LAV question very easy. So let's start off just looking at a simple length and area. Example, we have a square with length L and area L squared. Now if we double the length, so the side length becomes 2L, then the area becomes 4L squared, because as you can see the length is now 2L, but we have 4 squares. Each one has an area of L squared, so it's 4L squared. So doubling the length increases the area by 4. If we treble the length, we now have side lengths 3L. We now have an area of 9L squared. We have 9 of these squares. So trebling the length increases the area by 9. And you can see the pattern here that the area is increasing at the same rate as length squared. So area changes at the same rate as length squared. Multiply the length by x and the area will increase by x squared. So we don't need to work out the area. If we know the original area and we know there's been an increase in size, we can tell what the new area is. Let's expand this to length, area, surface area and volume. Length is L of this horribly drawn sugar cube. The surface area is 6L squared because we have 6 sides, 3 we can't see, and each one has an area of L squared. And the volume is L cubed, L times L times L. And if we double the size of each length, the side length is now 2L, 2, 2, 2. The area is surface area is 24L squared. This side has an area of 4L squared, and there are 6 sides making 24L squared. You can see that it's risen by 4-fold from 6 to 24. Volume is now 8L cubed. There's 4 sugar cubes on top and there's 4 sugar cubes on the bottom. You can't see them all. So volume has increased 8-fold, which coincidentally of course is 2 to the power 3, 2 cubed. So surface area changes at the same rate as length squared, and volume changes at the same rate as length cubed. And that is the LAV rules. The length, area and volume rule. Area is proportional to length squared. Volume is proportional to length cubed. Classic LAV question. 2 objects, A and B, are similar. I haven't drawn them. Well, you can imagine that these are over here. A has a height of 20 and B is 40 tall. B has a volume of 600 cm cubed. What is the volume of A? Well, the ratio of lengths is 2. The ratio of volumes is going to be 2 cubed. So that's 8. So when you've increased your, from B, when you've increased your height doubled, the volume increases by 8. So B has a volume of 600, so A has a volume of 600 over 8 equals 75 cm cubed. Let's go and see how you can make this simple. Most LAV questions are very similar. You are given 2 similar objects. You are given both of their lengths or areas or volumes. In the last case, it was both their lengths. And you are given the measure of another object where we were given the volume of B, and you're asked to find the same measure of the other object. So we want to work back to find the volume of A. Very simple. Let's think of a basic table that we can fill in every time and then just read off the answer, rather than having to give it a great deal of thought every time. And this is my solution, or this solution. Here's the question, as it was before, and here's the table. Very quickly, LAV, length, area, volume. These are the ratios. It's going to be L cubed and L squared and L cubed. And these are the ratios. So first thing we do, we enter the measurements we are given. Well, we're told one's 20 and one's 40 high, so that's your length, and you were given the volume here of object B. We can work out quickly that there's a ratio of 2 to 1 on the lengths, so we can work out L squared is going to be 4, L cubed is going to be 8. The ratio of surface areas is going to be 4, the ratio of volumes is going to be 8. And now we have 600 as the object B volume. We divide by 8 to get 75. Fill out this table, and it takes moments, and you will not make a mistake. You won't go the wrong way and multiply when you should divide. Let's have a look at a question, or rather, let's give you the opportunity to do a question. I'm going to ask you to pause the video now and try this one. It's a lot easier if you do the table. And here is the answer. As I see it, there's the table, and we are given these two measurements. This is a different question. Oh. No, I've rewritten this, but I haven't changed that. Oh, I'd stop there.